Bienvenue ici. Um, as this friendly guy already said, my French is far from perfect. It's just a very little bit. So please excuse me for doing the rest of the presentation in English. I hope you will be able to get the grasp out of it. Before we get started, can I take 1 minute and take a picture of you? Because this is an amazing room to be in, and so good to see so many people of you, if you don't mind. You may wave or something if you. Thank you so much. Thank you. Amazing. All right. With that out of the way, my name is Maarten Mulders. I work at InfoSport, Dutch IT company. We do consulting, we do operational things. But today I'm here because I'm also a regular committer to Apache Maven, which I happen to do in company time, by the way. That's amazing. I get to work on an open source project and I even get paid for it. And today I want to share with you a couple of things that we are currently working on in the broader Maven community. So that is the core Maven team itself, but also projects that are somehow related to Maven. We are in France. France is well known for its cuisine, its love of good food. I also love good food, so we share something here. And that's why I decided to go for this title, What's Cooking in Maven? And we will be doing this with a menu, of course, because food is always on a menu. I know we've just had lunch. You may not be thinking yet of your dinner, but let's just imagine what dinner is going to be. Our entree is going to be the Maven Wrapper. Le plat principal, that will be the build/consumer POM, which may sound a bit cryptic, but I'm going to explain everything to you in a few minutes. After the plat principal, we will have a little fromage, which is going to be the improved reactor. And of course, we will wrap things up with a dessert, and that's going to be the Maven Daemon. Are you already hungry? Perfect. Even just after lunch, people are hungry. I love this country. I really love it. All right, so let's get started with l'entrée, and that's going to be the Maven Wrapper. And for all the topics, I'm going to tell you a little bit, what is it, why should we care about it, but of course, there will be demos to show you how it actually works. So, the Maven Wrapper. The goal of the Maven Wrapper is to make sure that if somebody clones your project, for example, from GitHub, that you don't actually have to give them instructions like, oh, by the way, you need a Maven version 3.5, but not 3.5.2 because there's a bug. And it cannot be bigger than 3.8 either, but it should be more than that. Basically, make sure that everybody can get started straight away by simply cloning your project and running the Maven Wrapper rather than Maven itself. The Maven Wrapper is a utility script that runs on all major operating systems, so that includes Linux, macOS, Windows, and Solaris. And your users will actually download the correct version of Maven, correct in the way that it is the one that you expect them to have, when they first invoke the wrapper. Now, this is something that has been around in the Maven ecosystem already for quite some time, as the Tikari wrapper. You may have seen it. I even the previous presentation I visited, the speaker was using the Maven wrapper, and that's something that you typically generate just once, and maybe you update it every now and then, and that script goes into your version control. And the Maven wrapper, as I said, has been there as part of Tikari, but it has recently moved into the Apache Foundation. So now it's officially a part of Apache Maven, rather than a third-party tool that is provided for you. So, as I said, there will be demos, but you can't have a demo without cooking. So now we move to the kitchen and we start cooking. So for the Maven Wrapper, as I said, the first thing that I quickly want to show you is that there used to be a Tikari wrapper. And you would typically invoke it like this. I hope the font is big enough even for the people in the back to read it. Can you please confirm by quick? Perfect, thank you. So what we do here is we invoke Maven and we say run the Tikari wrapper plugin for me, and I want to generate a script for Maven version 3.8.5. And if you do this, you will notice that now we have a Maven W script, a Maven w.cmd, that's for the people running on Windows. And when you invoke it, for instance, like so. It takes all the same arguments as Maven itself does, and it will download Maven for you. Well, I had already downloaded it before, so we're not seeing it being downloaded, but we can inspect our M2 folder, and I believe it should be there. Wrapper, there it is. Distributions, Maven 3.8.5 bin, and there, there we have our Maven installation. If we have a different project that also uses Maven 3.8.5, it will use the same distribution that has already been downloaded here. Now, I'm going to remove the wrapper scripts. And now I'm going to run the Apache provided wrapper. And it looks pretty familiar, except that we don't have to do the io.takari whatever. We have a new lifecycle introduced here, which is called the wrapper lifecycle, and it has only one goal that we can reach, which is the wrapper goal. And it will basically generate the same scripts. There may be a few differences in terms of copyright statements and so on and so forth, but it's exactly the same setup. Now, why is this beneficial? And for that, I'm going to spin up a clean environment with a Docker container using Java 17. Well, there we have it. And I have the project folder that I was just using mounted inside this project. So this is my project again, but now I am in a Docker container. I do have Java 17 installed, but note that I do not have Maven installed on this machine. That's a pity. I would love to use Maven, but I don't have it. I don't feel like looking it up in the documentation, but I can use the Maven Wrapper script. And in this clean container, it is going to download Maven for me. This is pretty familiar if you're a Maven user, right? But if we do it again, it will be a lot quicker because everything was downloaded for us. And again, I can go to the wrapper distributions folder, and there we will see that Maven 3.8.5 was downloaded. So for all your users, they will have the same version, and they will have the version that you actually expect them to have. So far, any questions? Quick one then. What's the goal of this part? Honest answer, I don't know. It's probably just there to make sure it's unique, but I'm not 100% sure. Okay, one more please. Do you need to use Docker? No, you don't need to. I spun up the Docker container to make absolutely sure to every one of you, I have a clean environment, I'm not cheating. All right. With that answered, let's get moving, because after the initial food, it's time for le plat principal. This is where it really gets interesting, right? Both in terms of food and in terms of Maven. For the plat principal, I have selected the build/consumer POM. And I already said this may sound a bit cryptic, so let's dive in. Now the main goal of this sub-project, because actually build consumer POM is almost a project in itself, is to decouple the pom.xml file that you have in version control from the pom.xml that eventually ends up in, for instance, Maven Central or your company repository, your internal repository. Let me show a little diagram for that. Right now, if you have your project, you clone it, there's a pom.xml, and when you run Maven deploy or Maven install, it's literally that XML file that gets straight into Artifactory or Maven Central or JFrog or whatever repository you are using. And this is of course simple, it's easy to understand, but it has its disadvantages, as we will see in a minute. The goal of the build consumer POM separation is to actually cut this connection and to say the pom.xml that is in version control can be a different one than the one that we will be deploying to Maven Central. Why is that interesting? There have been already a lot of questions from the Maven user base to say, hey, can we change a particular part of the POM, of the model? And the POM it's the project object model. It's described by a schema, an XML schema, that quite precisely says this needs to go there, this needs to go there, this is required, this is optional. Now imagine I would be on Maven version 7. It doesn't exist, but let's say for a minute I have Maven version 7 and I have a future version of the XML schema, but then some of the users of my library is using Maven 4, which doesn't exist either, but this is a future scenario here. Now in my version of Maven, I can do a lot of things that were not possible in Maven 4. If I would have deployed literally my pom.xml to Maven Central, then everybody who is not using the same version will actually have a failing build, because they will download the pom.xml from Central. That's the consumption part, right? And their Maven version will say, but this isn't valid. This is just garbage. I can't use this. Whereas on my side, when I build the project, and that's the build of the build consumer, my version of Maven will say, but this is totally perfect. This is a valid XML, let's ship it already. So we decided if we want to evolve the schema at some point, then the first thing we need to do is make sure that these two are not required to be the same. That's what build/consumer POM separation is all about. And as I said, this is actually a cornerstone to allow us to further evaluate and evolve the POM schema without having a lot of negative impact on people using our library. Because nowadays we can safely say that the POM, as we know it, is quite a cornerstone for Java development, and even for sometimes for Kotlin and for Gradle. For Kotlin or for Scala, because even tools like Gradle and the Scala build tool will eventually publish a pom.xml to Maven Central. So the whole ecosystem, build tools, security scanners, IDEs, they all rely on the POM, and they rely on the POM so that they can understand it. If we would be changing it at this point in a way that would not be backward compatible, then basically everything would be broken, and we can't afford that. So that's what the build consumer POM, the whole idea, is about. And this is a very complex topic, and I'm sorry to disappoint you up front, but the demo is rather boring. Just so you know, I have warned you. I'm using Maven free here, and I'm making that very explicit by invoking mvn free. Just to make sure. Why is that? Because I also have a snapshot of Maven 4 on my machine. And this way I can show you which version of Maven I'm going to use. So this is Maven free, and I'm going to package my project. That's fine. Now I'm going to make a little change in the POM. And I'm going to remove, let me see, what was it again? This one. So the version element of a parent reference is required right now. If I'm going to package my project again with Maven free, it will say, you violated the schema. This is not okay. On the other hand, Maven 4, which has the build consumer separation built in already, and as I said, this is a snapshot, but it should work, it builds the project just fine. To say even more, I can not only package it, I can even install it in my local repository. And now we can look up the POM that was deployed there. Let me see, repository, demos, child 1.0. And there we see that the version that got installed in my local repository does have the version in the parent reference, whereas my project in my build directory did not have it. As I said, it's rather boring. Oh, I can remove one line from an XML file and it gets put back. It's not that exciting. But if you know why we are doing this and what this will enable in the future, then maybe this helps to be a little bit more excited and helps you understand why I chose this relatively boring topic as our plat principal. Any questions on this one? No, just one or two. We'll have questions at the end too. So, but say again, please.
How Maven resolve the current version?
How does Maven resolve the parent version in this case? We basically say this is convention. You did have a version of the child module. That was 1.0 snapshot, and if you do not explicitly specify, we will assume by convention that your parent has the same version number. I see no more raised hands, so we're good to go, I guess, for the fromage. And then again, that's something we have in common. France is a country of cheese. I'm Dutch. We're also famous for our cheese, so we just don't have it for dinner. That's maybe the difference. So, le fromage. This is all about the reactor. And I'm going to show you a few things that we have improved in the reactor, which are heading for Maven 4. Since Maven 3.1, if I'm not mistaken, we have the option to actually build projects that consist of multiple modules. And that's probably something you've seen in your daily use of Maven. Is anybody using multi-module projects, like on a daily basis? That's roughly 2/3 of the room. Well, that's great. Then at least we didn't do it for nothing. I'm happy to hear that. You may be familiar with multi-module projects, but there's actually projects that take it to the next level. I mean, on my typical consultancy job, we have, well, maybe we have 5 modules in a project. If we really go wild, we may have 20. That's roughly the size of the Maven code base as well, if I'm not mistaken, roughly 20 modules. 26, I think. There's also projects like Apache Camel, which have 300s, somewhere about that. And there's projects like Quarkus, which have like 700-800 modules. And they are nested in a lot of levels. But there have been a few issues in Maven, which only occurred in multi-module projects. And they are one of the reasons that people still do Maven install, because these issues prevented them from using Maven the way we actually intended it to be used. The part of Maven that we had to touch for this is called the reactor. And the reactor is the part of Maven that is responsible for saying, okay, what do you actually want to build? Which modules in your project do I need for that? And in what order should I build them, keeping in mind that there may be dependencies from one module to another. The thing is that in a lot of these cases that I was previously discussing, it turned out that the reactor was basically ignoring the fact that the project it was currently looking at was part of a multi-module project. So it would just look at the pom.xml in a folder and say, yeah, that's fine, that's one project. But then if your project had a dependency on a sibling module, it would not recognize that there was actually a parent and that the parent had another child and that that child was a dependency of the first one. So what it would do, it would simply go to your local repository, the ~m2 folder, right? And if it couldn't find a dependency there, it would even go to your company repository or to Maven Central and look for com.mycompany.shared.lib.whatever, which somehow is not on Maven Central. I'm still surprised by that, but it's not there. And it would fail the build. What we did, we ensured that the reactor, before going to resolve the actual projects, first built the model of the whole project. So all the parent modules, sibling modules, child modules, grandchild modules, whatever, are taken into account. And only then we start trimming Okay, you don't want to build this, you don't want to build that, you have a dependency there, let's resolve that. And the only requirement that we have for this is that the root project, the root of your project needs to have a .mvn folder. That's a way for us to say, this is where my project stops. Going up in the directory tree, somewhere we need to stop scanning for pom.xml files and say, okay, this is apparently the root of the project. So this folder, if you don't have it already, let me give you a tip. Add it, create an empty file inside it, because otherwise you can't commit it into Git and push that, as it will be a great improvement of your day-to-day use of Maven when Maven 4 is there. Because you no longer need to do Maven install before you can do Maven build only this particular module. Well, that was a lot of words, and I think this is way better described if I just show you what is happening. Quick question already? This is also going to be Maven 4, but I'll get back to that at the end also. Don't worry. All right. So, let's see. Here we have a project, which is, well, we're a Java developer, so I figured something with coffee. I see that the contrast is a bit bad down there. Maybe it becomes a bit better if we do it like this. I'm not sure. Well, the idea is, I'm sorry for the lack of contrast here. We have an application that is, of course, programmed against interfaces, not against implementations. So we have a coffee shop API module, a coffee shop impl module, which has the implementations of all the interfaces. And then we have the coffee shop app, which actually packages the whole application together. And what I am going to do first is I'm going to make sure that my project builds. With Maven 3, that is. Which is rather disappointing. Apparently we're doing some kind of test-driven development because we have a failing test, so we're supposed to be fixing that test before we can continue, right? But look at this little line at the end. It says, hey, if you managed to fix the problem, in this case, fix the test case, you can just resume your build by saying -rf, which is resume from, and then coffee shop impl, because the failing test is in the implementation module. So let's make sure that I can actually do that. I can say resume from coffee shop impl. It feels even quicker because I forgot to say what I want to do. I want to verify the project, but still it feels even quicker. And this is exactly what I was talking about a few minutes ago. It says, I don't have the API for you. I have a dependency on the coffee shop API, but I can't resolve it. I don't know where it is. And you and I would probably be like, look there, in the folder next to you, there it is. But unfortunately, there's no way to use subliminal messaging and tell this to Maven, so this is illustrating the problem. And what people would be doing, they would be working around this. They would go to the root project, they would say Maven install, and then they would go back here and say, okay, now I can do resume from, which does fix the problem. Well, it's a workaround actually. It doesn't really fix it. It just makes sure that what we currently have as the API module is resolvable. So let's try again with Maven 4 and also do Maven verify. You may, by the way, also note that the console output is a lot wider. That's also something that we changed in Maven 4. It's a little thing, but given the fact that we don't run on 80 character terminals anymore, we figured it might be a good idea to change this in the 21st century. So then again, my test still fails because I haven't fixed the test still. But Maven now says you can resume. So no longer resume from, where it's basically saying, okay, module A failed. I want you to type the name of the module again so I know where to continue. We've turned it a bit around and we're saying, hey, we remember where you left off. So you can just say resume. And now it will actually resolve the API module from the same project structure, and it will try to run my tests. Well, I haven't fixed the tests still. I'm a bit of a lazy developer. But at least the project no longer fails with, I can't find the API module. It fails with, I found the API module, I ran your tests, but they failed. How about you go fix that test? I think this may be a good moment to actually do that. That's the wrong one. Let me see, what shall we do? I think we can just go for this. And say again, verify, resuming from the previous module. Now this is always a bit scary, doing live coding and in VI, so that's, at least I managed. The test is good, the build succeeds. So far so good. This is already quite a big step, and the funny thing is it may look as if it was simple, but actually building this was rather complex. Now, while we were at it, we changed a lot of similar use cases as well. Things that you previously could not do, but now you can, is, for instance, you can say, build me the implementation module, and also make the dependencies that we need. And then still you need to say what to do. This used to fail in Maven 3 as well. Now it works. We can say, for instance, rather than specifying a project list, we can say, here's my coffee shop implementation module, there's the POM file, please build it for me. And I don't actually even need to say -am, because it will still resolve the dependency from the project, as I said before. And we can even do this. It's going to be a bit scary to try, but we should be able to do this from a completely different directory. Wrong project, REACTOR. Fingers crossed, still works. Also, this was something that would not work in Maven 3. So, again, here it's very important that we actually do have this little MVN folder over there. I should really work on my contrast. I'm sorry. There is a .mvn folder there, and there's an empty file inside it just to make sure the folder exists. So, this is really, this is a potential time saver, I would say, because people having had the habit of doing the workaround and then going back, and then, well, you no longer need to. Any questions on that one, by the way? Yes, please. If there's a use case for the -am also make, yes, I would say there still is. If only because, for instance, you have changed a few files in both in two modules, and you want to see if the combination of these changes still works. Then you can say, okay, build me the project up until there, and please include all the previous dependencies. Yeah. All right. Last round already. Le dessert. C'est dommage, n'est-ce pas? I mean, we had this great dinner, and it's already time for dessert, which is about the Maven Daemon. So, Maven Daemon, it's all about? In one sentence, it's a bit like the Cradle Daemon. I'm sorry, I can't summarize it in a different way than just pointing at somebody else who already did it. The goal of the Maven Daemon project is to make your Maven build faster by having a daemon process. So the daemon process is running in the background and is just waiting for you to submit build commands. This background process keeps the JVM warm, so it saves us a couple of seconds in booting up the JVM, but it also keeps the plugins warm. So as soon as we build a project and we have plugins loaded, it will keep the plugins in memory. And this also helps in speeding up the build, because otherwise we are building the project, booting up the JVM, inspecting the POM. Oh, look, I need to find this plugin and I need to activate it. I need to load it into memory. I need to find which mojos there are, etc., etc. A lot of work. And we keep them all warm. And what it also does, it runs your project multi-threaded by default. Now Maven could already run a multi-threaded build for a couple of years, but the thing is, it would dump all the logging output as it happens. And now imagine you're not on a regular 16-core MacBook, but one of those shiny new ones with, what is it, 20, 30, 40 CPU cores? And you do, oh, hey, look, I have 40 CPU cores. Maven, capital T, 40. Imagine 40 threads logging their build output at the same time in your face. Good luck figuring out which lines belong together and which do not. This is something that the Maven Daemon also solves for you by basically grouping the output of each of the threads and then presenting it to you as the user. So let's see how that works in practice. And for that I have a different demo project. This is a relatively simple project, except for the fact that it uses the Maven Scala compiler plugin, which is a bit of a slow plugin. It needs to load, which takes a relatively long time, and it needs to find the Scala compiler, maybe even compile a specific bridge for your version of Scala. So this plugin takes a little bit of time. First, we are going to verify that we actually have the Maven Daemon running. Used to be more fun when it worked. Double hyphens. So I already have my Maven Daemon running, but I can just kill it for the sake of it. Like so. Maven Daemon version. And now it says, okay, I'm going to run a new Maven Daemon, and it will say, hey, this is running on Maven 3.8.3. Right now, the version of Maven that comes with the daemon is relatively closely coupled. And I think there's quite a few requests already to at least upgrade it or maybe even make it configurable, but we're not there yet. Anyway, I can run the status command again and it will say, hey, you have one Maven Daemon running, it's loaded with a Java 17 runtime and it's not doing anything right now. Great. Now I'm going to compile my project using a regular Maven installation, and you see it is loading the Scala Maven plugin, it's compiling the bridge, and it takes roughly 5 seconds. And if I do it a second time, 2 seconds, and 2 seconds. Now I'm going to do it with the Maven Daemon. First time, there's no notable difference. Takes roughly 4 or 5 seconds. Second time, boom. This is the effect of a warm JVM and warm plugins. Boom. Sub-second. Sub-second. Again sub-second. We've tried 5 times. I'm relatively sure by now. This is the effect again of having it warm and not having to boot it up every single time, right? But there's more you can do. Let's go to, yeah, why not? We do have some time. Let's go to the Maven source code itself. Living on the edge. And I'm going to run Maven decompile, and now you see the multi-threaded build by default. There's more than one module, so it can actually run more than one thread at the same time. I'm not getting cluttered output. It's just saying, hey, this thread is working on that part of the project. And it takes 13 seconds. And just for comparison, but this is going to take a while, so take a sip of your water. I will do the same. I should actually have done clean compile, then the difference is even bigger. Also 13 seconds, so yeah, just for fun and giggles, right? because I think this is typically around 1.5 minutes normally if you don't have like the result of the previous compilation. And this is because by default Maven will not run multi-threaded. So it's running all those 26 modules in sequences. Where are we? We are at 20. Oh, it's not that bad. It's 25 seconds. The last time I rehearsed at home, I think I was on battery rather than on AC, so it took a lot longer. But then still, for measurements, 25 seconds versus, oh, do we expect 10 seconds? We're 95%. 13 seconds. That's both a clean compile, so it wipes your build target folder and builds it all clean. You can have additional statistics, which can be very interesting if you want to inspect why your build is taking longer than you expect, and that you enable them by saying Maven minus capital D Maven D dot build time is true. And if you run it like this, well, we need to wait another 15 seconds. I'm sorry for that. But it will also give a nice summary how long each plugin took to run. Can be very useful if you're frustrated by your slow build and you want to blame somebody or something, then this one's your friend. All right. That was a dessert. Are we there yet? Not yet, completely. I want to tell you a little bit about when can you expect this. When can you use it for yourself? The Maven Wrapper is already working today. You can start doing that yesterday even if you wanted to and if you were aware of it. But yesterday is gone, so it's going to be today. You don't need anything special for it, just works. The build consumer POM. This is going to land in Maven 4, first of all, so it's not finished yet. And that's why it's no green status. But also, and that's a word of warning, not all plugins are compatible. We are currently working very hard to have all the plugins compatible with this new setup, because they need to know that they should look at the consumer POM rather than the build POM, or maybe they should not, but it depends per plugin. Not all plugins may work already. Then the improved reactor. So this is all about the resume from and the resume and whatnot. This is also going to land in Maven 4. And then finally we have the Maven Daemon, which already works, but not if you have this shiny new MacBook with 40 cores, because that runs on a different CPU architecture. Also, if you have a plugin in your build that is non-thread safe, the Maven Daemon will just say, I don't care, I'm just going to run in a multi-threaded mode anyway. So then your project may fail because of that. So that's definitely something you need to check before going to do this by default. Now, as I said, for a couple of features, we're not there yet. It hasn't been shipped yet. And this is where I'm going to ask for your help. You, as people interested in Maven, people actually using Maven probably, you can actually help test drive these features. And try them on your project. We've seen some great bug reports, for instance, from the Apache Camel community that were running snapshot versions of Maven 4, seeing all kinds of interesting behaviors. Interesting is just a synonym for bug in this case, but you figured that. And it would be even better if you were able to isolate the problem into a reproducing project, just a tiny project that has only one thing, which is the bug that you ran into. And if you could submit that to us, we have Jira for that. That is going to be a great help for us as a Maven committers to actually investigate the problem and find a solution for it. If you're curious for all the demos that I gave and how it all works, please check out the GitHub repository. Should be public by now. I made it public this morning. It has all the demo projects. It has references to documentation. It has, if I'm not mistaken, there's even like sample scripts that you can run, but if they are not there, feel free to reach out, because then I should definitely add them. And this allows you to play around with these new features that I have just shown you. And with that, we have 5 minutes left, and there's room for more questions. Anyone, please? Yes? Say again, please? Do we need an... Oh, administrator rights. Do we need administrator rights to run Maven Daemon? I'm not 100% sure. I don't think so, because what I would say from heart is it runs in your user space, the process. So I don't think you don't need to be an administrator for that. Anything else? Yes, please. Can you combine the wrapper and the daemon? That's an interesting one. Well, right now you cannot, because the wrapper is flexible in terms of which version of Maven you can have it download for you, whereas the daemon is hard-coded to Maven 3.8.3. So it's 3.8.3 and nothing else for you, sir. That might be an interesting thing to investigate, actually. I think right now it's either one of them, but you cannot have two. Anybody else? Oh, that's a lot of hands at the same time. Yes. Yeah, sometimes Maven tells you all classes up to date, nothing to recompile. It checks the, if I'm not mistaken, it checks the timestamp on the source files. Bless you, checks the timestamps on the class files, and if the class files are newer than the source files, then there's no way that you need to compile anything. And it's basically telling you that I'm not going to do anything because everything seems up to date. It's nothing new as far as I know, by the way. I think it's been there quite some time, but that's something that the compiler plugin takes care of. Yes, please. The most popular question, is there a release date for Maven 4 already? And the honest answer is no, there's not. We don't have a schedule or a plan. We do have a list of things that we deem absolutely necessary before making even a first snapshot available, or an alpha release if you wish. The version of Maven that I'm using here in the demos is literally the latest bit from the latest green build on Jenkins. So I'm downloading that in an automated way. I've got a homebrew package for it that just updates the latest green build from Jenkins, pulls that in and says, this is now your Maven. And I've been using that for more than a year. For me, it has been stable, but hey, I'm not working on Quarkus or Camel or something like that. So on my relatively small projects, it runs without any issues. I'm afraid we will have more questions than we can answer before time is up, but then just find me outside the room, okay? Let's have that straight. Yes, please.
How hard is it to migrate the comps from V3 to V4?
Is it necessary to migrate your POM from Maven 3 to 4? At this point, no. You can run an existing project with Maven 3 or 4 and it will both work. Yes, please.
Why the Maven Daemon is another command line? Why the Maven Daemon is another command line?
Why is the Maven Daemon another command line? The Maven Daemon is Maven D because it's actually it's a command line utility that talks to the daemon. So we're not talking to the daemon by invoking it directly. The daemon is running in the background, and using Maven D, we have a command line utility that just sends commands, messages to the daemon. And that's why I said it is not available for Silicon yet, because it's a native executable. And it's more or less of a client-server architecture, if you wish. You would like to have it as a default?
Yeah.
Ah, thank you. I had a no. It's no problem. It's just me not understanding it. What I think you can do is you could create an alias on the shell, so as to say. but I'm not sure it's going to work in all cases. So your mileage may vary there. And with that, we have run out of time. The light is blinking there. Thanks a lot for your attention. And again, if you have any questions, reach out on Twitter. Find me outside. I'm going to make room for the next speaker.